Sam Karana, Arctic News FAQs. When will Arctic sea ice disappear? Most sea ice looks set to disappear in September within a few years. For other months, it may take a few more years for most sea ice to disappear. This is the conclusion when calculating an exponential trendline using annual sea ice volume minima. Why volume? It makes sense to look at volume, because the thinner the sea ice will get, the bigger the chance will be that the increasingly intense and frequent storms will smash it to pieces, leaving only a small rim of ice along the edges of Greenland and Ellesmere Island. Why minima? Clearly, when examining the danger of disappearance of Arctic sea ice, it makes sense to compare annual moments when volume is at its minimum. Why an exponential trendline? A linear trend would be inappropriate, given the increased impact of feedbacks that can each be expected to reinforce sea ice decline, while there can also be interaction between these feedbacks, further accelerating sea ice decline. Albedo change is one such feedback, but there are numerous other ones, such as storms that have more chance to grow stronger as the area with open water increases. In conclusion, an exponential trendline is more appropriate than a linear trendline, as also illustrated by the image above that illustrates that a linear trendline has 9 years fall outside its 95% confidence interval, versus 4 years for an exponential trendline. The data were produced by the Pan-Arctic Ice Ocean Modeling and Assimilation System, Pyomas, Zhang and Rothrock, 2003, developed at Polar Science Center, Applied Physics Laboratory, University of Washington. An exponential trendline shows that sea ice looks set to disappear in 2019, while its virtual disappearance in 2015 is within the margins of a 5% confidence interval, reflecting natural variability. Indeed, natural variability could bring about a collapse of Arctic sea ice soon. The thinner the sea ice gets, the more likely such an early collapse is to occur. Global warming will increase the intensity of extreme weather events, resulting in stronger winds and more intense storms raging over the Arctic Ocean that can break up the thinning sea ice in small parts. Much of the sea ice loss already now occurs due to sea ice moving along the edges of Greenland into the Atlantic Ocean. As there will be ever more open water, the smaller parts can be more easily driven out of the Arctic Ocean.